This is lesson 9, looking at our data storage unit of work, in particular numbers. And today we're going to be looking at how to convert between hexadecimal and denary. We're going to explain how hexadecimal is converted to and from binary as well. Here are keyword walls. Remember how these work. Now, we started the lesson by going around the room and trying our counting game again. See if you can add the next line after 2f. Now, for the exam, you're going to have to be able to convert from hexadecimal into denary and denary into hexadecimal. So down the right hand side, I've just put base 10 and base 16 just to help you. So you can see that 11 is the same as B, 12 is the same as C, 13D, 14E and 15F. I'm going to ask you to create a recipe. Now, your recipe is going to be how to convert to binary and hexadecimal. We're going to do that shortly. Watch the video and try and write down what you do. Here are the answers. Number 1, convert denary to binary. Number 2, split it into 2 nibbles. Number 3, convert it into hexadecimal. Let's have an example. Let's convert 72 from denary to hexadecimal. So first of all, we convert it to binary. Here is our 72 in binary, 64 plus 8. We split into 2 nibbles. Now notice when we do that, we use 1, 2, 4, 8 on both. That's because when we're counting in binary, we'd never start from 16, we always start from 1. So because we've got 2 different nibbles, both of them need to start counting from 1. Next, we convert it to hexadecimal. So we've got 4 and 8. So we look at the numbers at the top, 4 and 8, and we combine them. Look at how I've written base 16 next to it. The reason I put base 16 is because it can be really confusing. 72 in denary is 48 in hexadecimal. And that can get really confusing if we didn't know which was which. So when we're writing in hexadecimal, you need to be writing your bases as well. So base 10 or base 16 in subscript next to the text, just like I've done here. Remember, base 16 is hexadecimal and base 10 is denary. Let's try another one. 115 base 10 to hexadecimal. You can see I've put my base 10 here now. First of all, I convert it to binary. So we convert it to binary. You should be able to do this now. If you can't, you need to look back at our previous videos looking at how to convert to binary. We split the byte to form 2 nibbles. So we split that byte. Just like that. We then have to figure out how to add these up. So 4 plus 2 plus 1 is 7. And 2 plus 1 is 3. So that would be 73 in hexadecimal. Now let's look at a little bit more of a challenging example. So here we've got 115 to hexadecimal. I've put it into binary. I split it into 2 nibbles and then convert it to hexadecimal. But you'll see in red I've highlighted that 8 plus 4 is 12, but we don't write 12 because that's in base 10. 12 in base 16 is C, so we use C. 4 plus 1 is 5, so we just put 5 and it becomes C5 to base 16. Let's try another one. 115 10 to hexadecimal. That should have said 254, so that's just been changed. We change that to binary. We split the byte to form 2 nibbles. And you can see we've got 111 and 1101. Remember, our sequence goes 1, 2, 4, 8, because we never start counting from 16, we always start counting from 1. Look at our numbers here. Now 8 plus 4 plus 2 plus 1 is 15. 15 in base 16 is F. In the exam, I would recommend writing out a little table like this down the side so that you don't get it wrong. It's quite easy to get confused between 11, 12, 13 and 14, and it's much easier just to write this down to make sure you get it right. 8, 4 and 1 is 13, which equates to D. We put those together and that becomes FD16. Now when we do hexadecimal to denary, we do the same, but we do it backwards. So FD16, we split them into two nibbles. Exactly the same, 1, 2, 4, 8. F is 15, so we have to represent 15 in binary. D is 13, so we have to represent D in binary. We join the nibbles this time, and remember we go back to our normal binary sequence, add them up, and then that will equal 254. Now, I want you to get your mini whiteboards out and you're going to show me your working. Try and write 1A and convert that to denary. Then B2, then CA to denary, then 17 from denary to hex, and 250 from denary to hexadecimal. If you go into Google Classroom, I want you to try the binary conversions. See if you can turn them to hexadecimal. Pause the video and complete that now. Next, I want you to have a look at the answers and mark your work. Finally, I want you to try the exam questions on this. The exam questions can be found on Google Classroom. Go through the exam questions, and then once you've done that, mark them with your answers. And you'll find the answers at the end of your workbook. Make any improvements using purple pen. Finally, can you match up the triangles? Who can connect the most? Here's an example. The hexadecimal. FF is the same as the binary 11111111. Pause the video and try and complete this now in your workbooks. You do have some homework this week, which is an extended question and an algorithm. There's a subroutine hex that takes a denary number between 10 and 15 and returns its corresponding hexadecimal number. For example, hex 10 would return A and hex 15 would return F. Write an algorithm using the subroutine to convert any whole number into a 2-digit hexadecimal number. Be careful when you answer this because there's already a subroutine called hex that converts the numbers for you, as we said. So you don't need to do that. You just need to write the code with the functions working.